Hi everybody, I'm Håkon Dybdahl from AI Lab at SICT. Let's talk about the future of finding research. Traditional searches for literature and research is keyword-based. Norges Vitenarkiv, NVA, is already an excellent research archive. If you know the precise keywords for what you're looking for, like hydrogen electrolysis, for example, you get fast, reliable results. If not, it can be hard to find stuff or be confident that you found enough. Many searches results in hundreds of results, and it can be daunting to read and navigate. AI capabilities are getting more accessible and more expected. This can help the process, but how? So, first, to find the content, artificial intelligence understands what you're trying to search for, reading your text, not just the keywords, using multiple languages, semantics, and using AI to find relevance. Then, understanding and explaining the results, we can use not only show the summarization of the papers, but you can also find clusters, visualize them in 3 dimensions. You can plot timelines, and we can do engagement with the content. So today we'll look at how to improve discovery, improve understanding, improve engagement, and I would say a few words about how we can move from this prototype into a production system. So let's start by looking at a search. This is, not a very good keyword search. There are too many keywords. So basically you won't find anything in a classic keyword search. But this is what you are interested in. So, what can we do to help on this? So first of all, instead of doing like a very classic filtering based on keywords, so basically, if you try to filter on every word in a query, we won't find anything. But of course, there's a better way to do this, like PM25. You can look at each word, and if there's a very unique word, you give it a higher score if it matches, and you might not require that all of the words are matching. So if you turn on something a little bit simpler, not simpler, but if you turn on a different approach, you might see that you find something. Climate benefit of a future hydrogen economy, large-scale hydrogen production in Norway, possible transition pathways towards 2050. These are not super good results, but it took only 150 milliseconds to find them. This is still very classic search engine, like with some scoring. This is not AI as such. This is more statistics. But can we get better results? We can use what's called semantic search. In this case, I haven't used the most the best state-of-the-art model. This is a small embedding model. So what it does is to read through all the papers. So what you're seeing here is the results are from the NVA. It's about 2 million research papers. And we read through all of them and tried to understand them by giving them and creating a vector, as it's called, or an embedding. We're doing the same with the query, trying to read the query, trying to understand it, and then trying to figure out which understanding matches the best. And you can see that the first result, the role of research in reaching 2030 and 2050 climate targets. It doesn't mention hydrogen, nor does the next result. So this is not great. I mean, this is something, but it's not a big improvement. What you can do is also to combine the the BM25, the query search with or lexical search with the vectorization. And basically in this case we're getting the top results are the same as for the lexical search. So yeah, I know that some of the results below are improved, but not the top two. So what can we do to still this is not great. We're not seeing any good results. So let's add some more logic. So what we're doing now is letting AI read the query and rewrite it in a way so it's more suited for searching. It might be adding more keywords, rewriting it, filtering a bit differently. And what we're seeing is that we're starting to get results that make sense. The first results, it's about 2050, it's about hydrogen, and I think the next result is also fairly good. There's a 2050 you won't see because I'm on front, but yeah, it's getting better. This is we're finding something at least. So just by fixing the user query. And what we also see is that this takes some time because here I'm using a very sophisticated LLM model, so it takes a second. It might be worth waiting for though, and it might be possible to speed up this with a factor 20 at least. If you, of course, you need to give up some quality then. We can do better. We can basically let the AI read all the top 10 results and then figure out, re-rank them. And what we're getting now is the AI is shuffling the top 10 results. And we're seeing that, yeah, it's getting better, I think. But this is the only top 10 results. So let's say if you have something on the 15th position, which might be the case, you're not seeing it. So we can do something else. We are running a cross-encoder on the top 20. This means this is a bit different from AI scoring. AI scoring here is the LLM is reading all the titles and summaries and then thinking, and giving it a score, in this case 95% match. This is costly, it's a bit slow, it takes more than 2 seconds to do this. We can do something which is quite fast, which is called a cross-encoder. This means that we are running the top 20 results, we're taking the text and the query and then running them together and scoring them in what's called a cross-encoder. And this gives a score for each top 20 documents, and then we re-rank them, and then we send them to AI for re-ranking. And that gives us better results. And now we're getting to a point where, with all the AI stuff, we're starting to have a quite decent set of results. I mean, at least compared to having nothing, this is much better. And it takes a couple of seconds to generate this result set, but yeah, it kind of works. We can also just say that we want Norwegian results only, and then of course the query is translated into Norwegian and we're searching only Norwegian documents, and we can find there's a good pile of Norwegian document as well. And this is of course relevant for NVA that has a lot of Norwegian and English documents. So these are all the bells and whistles we have. We can turn on and off that we've been demonstrating. But you can also throw on yet another layer of AI to basically ask AI in the end to answer the question, not only find, rewrite the query and re-rank and all this, but basically take the top 10 and try to answer the question. Is this useful? Maybe. It kind of gives you an idea about the problem space. And Another thing we can do is to look at the authors, just to, if you want to understand a bit, who is doing what here, and looking at the authors and then trying to use AI to come up with some clusters and name of the clusters. This might be overfitting a bit, too many, not overfitting, but too many clusters, but still, environmental impact of hydrogen. There's 3 papers. Here are the authors, and these are how they're connected. This is probably not useful as is, but it shows that that maybe there is some you can make it useful. Another thing we can do is to look at the semantic value of this. So here what we'll see is like each bubble is one paper, and we position them in a space, and balls that are close together is a cluster. These are papers in the same area, and then I asked AI to name the cluster. So we're using the semantic understanding of the papers, creating clusters, and then you can go into various clusters. So this is a different model than using keywords to navigate. A more interactive session. Is this useful? Maybe we can build something on top of it. We can look at trends as well. Let's bring in the right query. This might help us understand, what's happening in this space. Again, AI is making the clusters based on subsampling, I think, in this case, and we can find emerging topics. We can find top categories. This can be useful to understand what's going on. We can look in the history. We see there a lot of stuff happened in 2020 and 2024. So hydrogen is still a hot topic. And then, we can engage more with the content. Let's do an interactive panel debate. Here you can put in a text, or you can write your own text, and then have experts discuss the topics, and you can be involved yourself.
While the idea that climate change is solely responsible for Svalbard's ice melt is popular, it's crucial to scrutinize the specifics. Duarte et al. 2020 show that warm Atlantic water contributes significantly to ice melt, implying that local oceanographic conditions must be considered. Additionally, Loftus et al. 2021 highlight that biodegradation processes might play a role, hinting at a complex interplay of factors. I believe the ice melt in Svalbard offers a fantastic opportunity for us to learn and adapt. The research by Aquino et al. 2025 on melt pond nutrient dynamics opens up exciting possibilities for understanding ecological impacts. Plus, Ryan et al. 2019 show how similar processes in Greenland could inform their strategies in Svalbard. It's a thrilling time for climate science. Addressing ice melt in Svalbard requires a balanced view. Platch et al. 2021 indicate that historical climate simulations can provide insight into current trends, helping us compare Svalbard's situation with Greenland's. Monitoring and mitigation efforts must reflect both ecological impacts and oceanographic conditions, as Duarte et al. 2020 suggest. It's about integrating diverse research findings for actionable strategies.
So, let's engage in the discussion.
My uncle says that climate change is a scam. It's understandable that some people are skeptical about climate change. However, extensive research, like Duarte et al. 2020 on oceanographic conditions, consistently shows that climate change is impacting ice melt in regions like Svalbard. While we must scrutinize all factors, dismissing climate change entirely overlooks the scientific consensus and evidence of its effects. I appreciate your uncle's perspective, but the exciting part is the wealth of research, such as Aquino et al.
Yeah, so I've shown you a fairly advanced prototype. We kind of stacked, layers of layers of layers of AI and machine learning and whatnot, statistics. And it's usually easy to create a prototype, but it's super hard to get into the production system. There's keyword matching. We had stemming. I didn't show that, but that's part of the solution or the prototype. We have vector similarity search. We have a hybrid that combines vector and keywords. We have this cross encoder for re-ranking top 20 results. We have AI to re-rank the top 10 again. There's embeddings. There is, and this needs to scale to millions of docs. And it needs to be stable in the production systems and all this. Can we create a production system around this? So what I've done in this prototype is to build on stable infrastructure, I hope to say. I use what's something called Vespa. It's developed in Norway, and it has been going on, I think, mid-90s or something. So it's very mature technology. It supports keyword search, vector search. It was very early on vector search. Keyword search is, it's been along for a long time, and it's been used in Yahoo for email search, ads, displacements, Yahoo Finance, a lot of stuff. It supports this double phase search where you first, bring in the rough set of documents and then you re-rank it. This is part of the architecture. The cross encoder is running inside Vespa. It scales in all kind of ways. It's super flexible. It can be super fast if you want to. It can be super reliable. It can be super fault tolerant. It can be configured in all kinds of ways. Disclaimer, I've been working on this. But my point is that by using this as opposed to coding everything yourself, a lot of the complexity is just configuration. It's not code. And having a stable base makes it the distance from a prototype to a production system is much shorter. And this, it means that this can scale basically. What I've been showing is a bit slow because I've been running a Vespa on very poor hardware. If you have modern hardware, this should be running much faster. Vespa does not cover all of the logic in the prototype. I'm using LLM models like query expansion, rewriting query in different languages, reading the result, summarizing, translating. This is done by LLM. You might run your own LLM. That's totally possible. In the prototype, this is bought by big tech companies. This should work well with lots of different companies. So it's a market for this. It's getting quite stable, or stable enough, I think, for this product. So, of course, there's a cost involved, and there's also a cost involved if you want to run it on your own. But the cost is predicted to go down. It's been going down like crazy for the last few years. So I think this is also not the cost might be a blocker, but hopefully it's not too expensive compared to the value it creates. But if you accept the cost, the move to a production system should not be very hard. So what are the next steps in this field? The prototype is rough. I scraped NVA quickly. There might be, fields I missed. There might be problems with some data. There might be, I don't know. I haven't spent any time trying to assess the quality. I counted the number of docs I inserted, and it's not 100%. It's not too far, but still there might be, errors all over the place. So, it's just a prototype. It's a proof of concept. I think if you want to continue, maybe a quality assessment will be needed. But I think also showing it to real users and getting feedback by the product teams will be a next step. There's something called OpenLX that contains about, I think, more than 300 million documents, which is research articles worldwide. There is nothing stopping us from putting all this in Vespa, except that it will need some hardware. It's totally doable, but it's a bit larger project than a quick prototype. So it needs some more backing. And also, we could iterate the concepts. Maybe, some of this is just for fun, I think. But if you think about the first, we started with a query that didn't find anything, and in the end we had a quite decent set of results. I think that's really interesting, and I think we can build on top of this. But of course, this is not a finished product. This is a prototype. To summarize, what we've done is to take the Norwegian research papers. That's all of the publications in Norway, and we stacked it. We put a lot of layers with AI in it, both for discovery, like query rewrite, semantic search, combining semantic search, BM25, cross encoders, AI re-ranking, AI summaries, and then we looked at ways to understand this, like timelines or auto network, clusters, 3D visualization of clusters. We looked a little bit into engagement, like in the interactive panel debate. Does it make sense? I mean, this is just one example. You can think of, setting up more like education system on top of this to play with it. Yeah. Also, I want you to take away that this is built on top of scalable tech, which is pretty cool. But again, this is just a proof of concept, so data is not good. It's possible to use the prototype, but yeah. All right.